Welcome to question 3 of the 2014 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For question 3 we are asked to solve the equation 2 cos of 2x equals negative the square root of 3 for x, where x is between 0 and pi included. So the first thing we're going to do to this equation is divide both sides by 2, just to leave the trigonometric term by itself. So we're going to find that cos of 2x is equal to negative root 3 divided by 2. And now that's an exact value for cos that we know, so we can come over to a unit circle and locate negative root 3 on 2 for cos. So cos is read off the x-axis and it goes root 1 on 2, root 2 on 2, root 3 on 2 in the negative direction. So we need the angle that is pi on 6 to reach that spot, and it's going to be negative in these two quadrants. So if we go halfway around the unit circle, that's the same as pi, or 6 pi on 6, and then we're going to go back pi on 6 and forwards pi on 6 to get two possible solutions to this equation. So what does that mean? That means that the 2x, the part inside the trigonometric function, needs to equal either 6 pi on 6 take pi on 6 is 5 pi on 6, or it needs to equal 6 pi on 6 plus pi on 6, which is 7 pi over 6. So multiplying the left hand side by a half will leave x by itself, and then we need to do that to all terms. So we're going to multiply everything by a half. So therefore we find just x is equal to 5 pi on 12, or 7 pi over 12. And now from the domain we can see that both of those solutions fit between 0 and pi, because we could have written this as 0 and x being greater than or equal to that, or less than or equal to 12 pi over 12. So we can see that 5 pi over 12 and 7 pi over 12 fit within the domain that we're looking for solutions. And now the only thing that we've got to do is decide if there's any other solutions. And one way of doing that is to consider a simple sketch of what's going on in this situation. So if we first consider the period of cos of 2x, we know that the period is 2 pi divided by n for any sine or cosine function, where the n value is the coefficient of x, so n is equal to 2 for this question. So the period is equal to 2 pi divided by n, which is 2, which just gives pi. So with a domain of 0 to pi, we'd expect probably two solutions. And if we continue with our sketch, if we just graph cos of 2 of x, that would look like this, between 0 and pi, because we know it takes one revolution is 1 pi. So that is y equals cos of 2x. And then if we were to sketch y equals negative root 3 on 2, that would be this line here. And as you can see, there's only 2 points of intersection, the ones we found just before, which were x equals 5 pi on 12 and x equals 7 pi on 12. So that is the answer to this question. From the examiner's report, we can see that 55% of students got full marks for this question. And the examiner's report goes on to say that many students were unsure of exact values and were not able to ascertain the correct basic angle of pi on 6, or they produced solutions that were beyond the specified domain. So finding the correct basic angle, it can help to use a unit circle, and to determine if you've found all the solutions in the specified domain, a quick sketch of a graph can help, if you have time for it.